welcome to yet another video on our channel Euclid Mathematics. We have started lecture series on a ring theory, and to check this video you may go through my playlist. You can find all the videos there. Okay, now in my today's video I will explain to you all one of the important topic from ring theory, which is a zero divisor. Most of the students, they are confused about the zero divisor. Okay, so in my today's video I will explain to you all in detail with the example zero divisor. Okay, now let's get started. So here is the definition of a zero divisor. So zero divisor means we need a commutative ring first. So ring need to be a commutative, and if ring is commutative, then second condition it says that we want the two element, where first element we have to take it from the ring, which need to be a non-zero, and the second element corresponding to first element we will get the second element, which is also non-zero, and when we multiply that first and second element we will get their product as a zero. Okay, so here we can see the definition. Let R under addition dot, okay, is a commutative ring. Okay, it need to be a commutative ring. Commutative ring means we need to satisfy A dot B which is equal to B dot A. Okay, so this is a commutative property need to hold for the zero divisor, and a non-zero element A belongs to R. So we have to select one non-zero element from the ring is said to be a zero divisor. Okay, that A, here it is a zero divisor if inside that same ring we'll get the some another non-zero number B which is from the same ring, such that if we multiply these two elements, first and second element, we will get their product 0. Then we say that R under addition dot is a 0 having zero divisor. Okay, now let me explain with one example. Okay, so if I consider here Z5, okay, if I consider here Z5 and I consider after that I consider one element A belongs to Z5, okay, and A which is equal to, sorry, you may consider Z6 here. Okay, so A from Z6 and A which is equal to 3 I taken. Okay, so A which is equal to I taken 3. Now I want the element there exists which is a non-zero, A which is equal to 3 which is a non-zero, and Z5 we know that it is commutative ring. Okay, commutative property always hold for Z5. Okay, so if I taken A which is equal to 3, there exists, I got the some another element which is a B. Okay, some another element B which is equal to 2. Okay, so there exists a B which is a 2 which is also non-zero. Okay, so if I got the A which is a 3 non-zero, B which is equal to 2 which is also non-zero, but their product A dot B. So A dot B, it says that 3 multiplied by 2 which is a 6, and under Z6 6 is having value 0. Okay, that means A is non-zero, B is non-zero, but their dot product A dot B which is a 0. So this is the definition for zero divisor. Okay, so with one example, short example I explained here the definition of a zero divisor. Okay, so A non-zero, B non-zero, their dot product is 0. Then B is a zero divisor of our ring. Okay, so this is the definition here. R under addition dot is a commutative ring, that A and B need to be a non-zero which is from the ring, and their AB dot product need to be a 0. Now let's get start some of the example depending on zero divisor. Okay, so here I consider Z15 first ring as a Z15, and we have to show R under addition Z15 under addition dot is having zero divisor. Okay, so now let's consider 3 as a non-zero from Z15. Then there exists a 5 which is also in a Z15. So if we multiply them, 5 non-zero, 3 non-zero, but under Z15 3 5s are 15, and 15 under Z15 which is a 0. Okay, so 3 is a zero divisor for Z15. So Z15 has a zero divisor. Okay, it is quite easy. Now let's go for a little complex example like a Gaussian integer some modulo 5i. Okay, so here next example, Gaussian integer modulo 5i which is having zero divisor or not. Okay, so let's consider some of the example from some of the counter example from Z5i and Zni. We are having Zni element like A plus Bi. Remember my Gaussian integer lecture. Okay, it is already I explained here how we can find the element from Gaussian integer. Okay, so here from Z5i I consider here A plus Bi. Okay, A plus Bi which is from Z5i, and one more consider, this is the element which look like which look like a Gaussian integer. Okay, so this is a Gaussian integer. Now consider two non-zero Gaussian integer from our zero divisor. So I consider here 1 plus 2i which is a non-zero which is from our zero divisor, our Gaussian integer Zni. Okay, Z5i. Similarly 1 plus 3i which is also from Z5i, such that 1 plus 2i into 1 plus 3i which is equal to 0. Now how 1 plus 2i and 1 plus 3i is a 0 under Z5i? We have to find out their product. Okay, as we do cross product or multiplication of a two order pair. So here, how can we multiply this two order pair? As we go for multiplication of a two order pair, similarly we have to use 1 multiplied by 1, 1 multiplied by 3i, 2i multiplied by 1, and 2i multiplied by 3i. So when we multiply this one, we will get the 0. Now how we get here? So I multiplied by 1 multiplied by 1, 1 multiplied by 3i, 2i multiplied by 1, and 2i multiplied by 3i. That means 6, 2 3 are 6, and I multiplied by I square. Okay. So 2i plus 3i, 5i, 1 as it is. 6i square means I square negative of 1. So negative 6, 1 minus negative of 6, negative 5 plus 5i. Okay. So negative 5, take negative sign common from there. So 5 plus 5, negative of 5 under bracket 5i. Okay. So under Z5, 5 and 5 both are having 0 value. Okay. So which is becoming 0. So A non-zero, B non-zero, but their product it comes 0. So Z5 has a 0 divisor. Okay. So similarly we can check it for the Z3i. So can we find the element which is a non-zero but their product is 0 in a Z3i? Okay, now let's check it. Z3i is having element 0, 1, 2, I, 2i, 1 plus 2i, 1 plus I, 2 plus 2i, and 2 plus I. Okay, how these are elements I already explained in my previous lecture. You check it into my playlist. Okay, so there is no any two non-zero element such that their product is 0. Okay, so Z3i do not have 0 divisor. Okay, so when if we take n which is a prime, okay, if we take n is a prime, then Zn do not have 0 divisor like a Z5, Z7, Z11. These prime number do not have 0 divisor. Okay, so always careful about it. But when n is a non-prime like a Z2, Z4, Z6, Z8, all these are having prime, all these are having 0 divisor. Okay, so let's show that Zp has a no 0 divisor. Okay, Z prime, if it is coming for prime, then it do not have 0 divisor. Okay, now let's show it for the next example. A belongs to Zp. Now take the two elements from our Z prime, okay, which is non-zero and the product is 0. Okay, so if A belongs to Z prime, B belongs to Z prime, such that A dot B, okay, their product is 0. Okay, this is the definition of a 0 divisor. So if their product is 0, that means whether A0 or B0. Okay, product 0 means their one of the condition need to be a 0. Here if P divides A then A0. Okay, if P divides A then A0, that means 0 divided by P it can be hold. Okay, so then A0. If P does not divide A, so if P does not divide A, that means two numbers cannot divide each other. That means they are having their GCD 1. Okay, that means their remainder always it comes 1. That's why P and A has having GCD 1. Okay, and if P divides B then B0. Okay, so if P divides A, I got the A0, and P does not divide A, we got the GCD of A is 1. Okay, or we need to select whether A0 or B0, then and only then it hold. Okay, A dot B is 0. Okay, so then ZP has a no 0 divisor. Okay, one of the condition need to be a 0 for holding A dot B 0. Okay, so ZP has a no 0 divisor. This is the quite easy proof. Okay, just only in a 2 line. So similarly Z2, Z3, Z5, as I explained earlier, which do not have 0 divisor. Okay, but when we take n which is equal not prime and bigger than 1, then Zn has a 0 divisor. Like example here I given Z4, Z6, Z8, Z9, Z10, Z12, all are having 0 divisor. So if you wanted to check whether it is having 0 divisor or not, you may take Z8 and find out the element from Z8. Take the 2 element counter example as a 2 element and find out their product is coming 0. Okay, so that's it here only for 0 divisor. Okay, so I hope you all have understood my today's examples along with the definition of a 0 divisor. It is quite easier to understand. Nothing is difficult on 0 divisor. Okay, so if you if you have any difficulty, doubt, let me know in comment section. I will come up with the different video too. Okay, so thank you everyone. Thank you for my today's lecture.